This year, the Kepler Space Telescope will die. For 9 years, it's been searching for exoplanets as part of the effort to eventually discover life outside of our solar system. Its primary mission ended 4 years ago, but it's continued its search and solidified its place in exoplanets research history. With the TESS mission launch upcoming and Kepler's retirement imminent, let's take a look back through the history of exoplanet discoveries. And let's use these little water orbs. This jar represents all the exoplanets that humanity knows about, and each orb represents one exoplanet. In 1989, the very first exoplanet was discovered via the radial velocity method, HD 114762b, a massive gaseous planet that orbits as close to its star as Mercury. As it orbits, the planet exerts a gravitational tug on its host star, which is observable from Earth using the Doppler shift. For 3 years after this discovery, we saw nothing until 1992, when a pair of exoplanets were discovered based on timing irregularities in a pulsar. 2 years later, another exoplanet was discovered around that same pulsar, smaller than Mercury, which still remains the smallest exoplanet ever discovered. 1995, radial velocity detection of 51 Pegasi b, and now things really start to pick up. Fast forward to 2002, Algol TR56b is the first exoplanet to be discovered by transit photometry, along with 29 other exoplanets discovered that year. It orbits its star at the exact right orientation so that it passes in front, dimming the star slightly. 2004, the first direct imaging of an exoplanet and the first discovery of an exoplanet by gravitational microlensing. Now as we get into the late 2000s, the exoplanet landscape begins to shift. The radial velocity method starts to become less important, and 2009, when the Kepler Space Telescope launches, is the last year that that method will be dominant. Kepler observes for 4 years on its primary mission, announcing hundreds of candidates every year. Then, in 2013, Kepler announces the discovery of 715 exoplanets, forever changing the science. 2 years later, in 2015, Kepler again announces a new 1,284 exoplanets. Now that the Kepler mission is coming to an end, what can we expect for the future? Can we expect another exoplanet explosion? Or are we headed for a dry spell? This year, the Transiting Exoplanet Survey Satellite, TESS, is launching, which is another transit photometry satellite just like Kepler, but with a few exciting differences. Hold up your hands at arm's length. The area of your hands is the entire field of view that Kepler observed. In that field of view, it observed more than 200,000 stars and found 2,000 exoplanets. But TESS is all sky. TESS will observe around 200,000 stars. So what can we expect?